All right, let's get right into it. You know, your web browser is an amazing piece of technology. It's super smart, but it has this one tiny kind of critical flaw. When you type in a website name like networkchuck.com, it actually has no clue how to get there. See, the thing is, to connect to anything on the internet, it needs a number, an IP address, not a name. So how does it figure that out? It's kind of like I gave you an old rotary phone and said, hey, call Bernard. You know his name, sure, but you probably don't have his number memorized, right? Well, your browser has the exact same problem. So how in the world does it find the one correct phone number out of the billions that are online? And that's exactly what's happening here. Just like you'd whip out your phone, open your contacts, and look up Bernard to get his number, your browser needs a way to look up a website's name to get its IP address. It's the same simple idea, just happening on a global scale at, the speed of light. And that giant automated contacts app for the entire internet? It's called DNS, the Domain Name System. It's the invisible magic that translates the names we can remember into the numbers computers understand. And listen, this isn't just a convenience. It is absolutely essential. Without DNS, the internet as we know it, websites, email, all of it, would completely grind to a halt. So to really get how this all works, we're going to do something fun. We're going to follow a single request on its journey across the internet. We're going to follow the clues from the second you hit enter and see how your computer finds its way home. Now, this journey has 4 main stops. Think of it like a little detective story. Our query starts at your computer, but it quickly has to ask for help from a chain of command, a series of more and more specialized servers. First, the recursive, then the root, then the TLD, and finally, the authoritative server. Let's follow the breadcrumbs. Okay, so first things first. Before your computer even thinks about going out on the internet, it does the smartest thing possible. It checks if it already knows the answer. Your PC has something called a Stub resolver, which is really just a fancy name for its own DNS client. And it checks its local memory, its cache. If you've been to that website recently, the IP address is saved right there, and boom, the whole journey is over before it even started. But let's say it's a brand new site you've never been to. The cache is empty. So your computer reaches out to its designated helper, the Recursive DNS server. You've probably seen these addresses before, like Google's famous 8.888. This server is our workhorse. Its entire job is to go out and hunt down the answer for you. And here's the really clever part. The recursive server probably doesn't know the IP address off the top of its head either, but that's okay. Its real superpower is that it knows exactly who to ask. It's like the ultimate networker. It's ready to make a chain of calls to find the answer. So where does it start its search? It goes straight to the top. It asks the DNS mafia bosses of the internet, the root servers. Now, there are only 13 of these root server constellations in the entire world, and they are the absolute foundation of this whole system. But the thing about these root servers is they're big picture guys. They don't know the specific IP for networkchuck.com. They only care about the very last part of the name, the top-level domain, or TLD, like .com, .org, or even .coffee. Their only job is to point you in the right direction, to delegate. So when our recursive server asks about networkchuck.com, the root server just looks at the .com part and says, whoa, not my department, but I know who you should talk to. Go ask the server that handles all the .com domains, and it points the query down to the next level of management, the TLD server. We are so close now. The query hits the .com TLD server. This server still doesn't have the final IP address, but it knows exactly who is in charge of the network chuck part, so it makes the final handoff, pointing the query to our last stop, the authoritative server. This is it, the one true source of information for that domain. And boom, the query arrives. The authoritative name server is the one that holds the master record. It looks it up and sends back the correct IP address, 104.18.42.139, all the way back down the chain to the recursive server, which then gives it to your browser. And the craziest part? This whole round-trip detective story happens in the blink of an eye, milliseconds. I mean, it's an incredible, beautiful, intricate system that just works. But you have to remember, it was designed for a much simpler, more trusting era of the internet. And it's fundamentally built on trust. Which, of course, begs a pretty scary question. What if, somewhere along that chain, the answer you got back was a lie? Here's the core of the problem. By default, all those questions and answers we just followed, all those messages flying back and forth, are sent in plain text. They are not encrypted at all. Think of it like sending a postcard through the mail. Literally anyone sitting between you and the server can just read it.
And this openness creates two huge threats. The first is DNS spoofing. That's when a hacker intercepts your request and sends back a fake IP address, sending you to a phony bank website instead of the real one. The second, and maybe even more common, is snooping. Because your queries aren't encrypted, your own internet service provider can easily see and log every single website you go to.
Now, that sounds pretty bad, and it is. But thankfully, the internet community figured this out and has come up with some really powerful solutions. We now have a modern upgrade to secure this decades-old but still vital system.
A major hero in this story is something called DOH, which stands for DNS over HTTPS. And this is a truly brilliant idea. It takes your normal DNS query, your little postcard, and puts it inside a secure, sealed, encrypted envelope, the exact same HTTPS connection you use for secure online banking and shopping.
So let's just break that down. With old-school standard DNS, your traffic is in plain text, totally visible to your ISP. With DAW, it's completely encrypted. But here's the real kicker. Because it's wrapped in HTTPS, your DNS requests just blend in with all your other normal web traffic, making it incredibly hard for anyone to even tell you're looking up a website. And DOH, while it's a huge deal, isn't the only game in town. There are other important technologies out there, like DNS over TLS, or DOT, which does a similar job. And then there's DNSSEC, which is a whole different beast. Its job isn't just to encrypt the conversation, but to digitally sign the answers to prove they came from the right server and haven't been messed with. So we figured out how DNS finds websites, and just as importantly, how we can secure that process. But mapping names to IP addresses, that's really just the beginning. DNS is more like the Swiss Army knife of the internet. It handles way more than you might think. So that A record, that's the one we've been talking about, the one that links a name to an IP address. But look at these others. An MX record, that's what tells the internet where to deliver your email. A CNAME record lets you create nicknames or aliases for a server. And TXT records are this awesome utility tool used for all sorts of things, like proving to Google that you actually own your domain. When you really step back and look at it, DNS is so much more than a phone book. It's the internet's invisible traffic cop, silently directing data all over the globe. It's the foundational system that makes sure your web browsing, your emails, and a ton of other services all get exactly where they need to go. We've just pulled back the curtain on one piece of the incredible hidden machinery that makes our digital world possible. It's a great reminder that under the surface of every single click, there's this amazing dance of invisible protocols. So I'll leave you with a question to chew on. What other hidden systems, just like DNS, are you depending on every single day without even realizing it?